Everyone, welcome to my YouTube channel. So here today we are going to do another full paper, which is the 2023 paper for MA110. So if you're doing NS, this is a really good paper that will help you, equip you for your test and exam preparation. So all these questions are going to be covered. So let's look at our first question. It says that if C is a subset of D, simplify if possible C complement union of D complement. So here you understand what C is a subset of D means. It means to say C is found inside D. So if this is D, then we have C there. So what we are going to have is that C complement union of D complement, we are going to say by De Morgan's rule, C complement union of D complement using De Morgan's rule is U changing whatever here. If we have we are going to have C and our D. Here we have union, it's going to change into intersection. Then we can more like put one complement outside like that. So now remember what we have said, C intersection of D. If C is a subset of D, it means to say C is found inside D. So this is C, this is our D. C intersection D means what is in common. So C intersection D is having shading our C, that's the common part. Then we are going to find that this is going to have, so C intersection D in the actual sense is just C. If C is a subset of D, then outside we have complements. That means to say we have found what our C intersection of union of D complement is equal to. Looking at our second question, it says that express our 1.171717 as a fraction A over B in its simplest form, where A and B are integers and B is not equal to 0. So to solve this one, so 1.1717 is the same as writing 1 point, the repeating, so 17 is repeating, so we can put a bar like that. So this is the same as this number. It is the same as 1.17, so this means to say the 17 is repeating like that. So the value continues like that. So we can write it in this form and say we are going to let our x be equal to this value 1.17 like that. Then the next stage is that we can just skip. All we want is there to be repeating unit after the decimal point. So we are going to multiply by 100. So we are going to have x is equal to 1.17 bar. We are going to multiply this by 100. Why multiply by 100? Because we want to move the decimal points twice so that we can have our repeating units. So 100 by x, this will give us 100. X should be equal to 1.17 times 100. It will give us 117 like that. So 1.17 times 100 means move the decimal points twice, which will give us 117. Now remember, the 17 is still repeating, so we are going to have 0.17 bar like that. Then if you have two numbers, so this is our equation 1, this is our equation 2. So if you have two numbers like that, you can, having the same repeating unit after the decimal point, you can subtract them. So you are going to say subtract equation 2 minus equation 1. So this is the same as having 100x should be equal to 117.17. We are also going to have another one is x should be equal to 1.17 like that. So all of these have got a bar. So we are going to subtract 100 minus 100x minus x. This will give us 99x should be equal to, we have 117.17. We subtract 1.17. This will give us a value of, so we are going to have here 17 minus 17 is 0.117 minus 1. This will give us a 116. So we are going to put 116. We divide 99, we divide 99, So our x value will be equal to 116 over 99. So as we can see, there is no number that can enter into both 99 and 16. So our answer ends here. So we have expressed in the form a over b, where b is not equal to 0. So as you can see, your a is equal to 16, your b is equal to 99, like that. Looking at our b part, it says that consider the operation a star b should be equal to a plus our b. Then we have minus 2ab, like that. Then the first part is saying that is star a binary operation on sets of real numbers. Give a reason for your answer. So for this one, the answer is yes. Why yes? Because for whatever values that you are going to use for a and b, it shall be a real number. So now, just as we have said, because for whatever you use for a and p, the result will be a real number. So this is what I mean. Let's say I was to say my a is equal to 1 and my b is equal to, let's say my b is equal to 2. I know my a star of b is equal to, we have our a plus our b, then we have minus our 2ab. Now when we say that a is equal to 1, we can put 1 there, b is equal to 2. That means to say where there is a, put 1. So we have 1 plus 2 minus 2. Where there is a, we are going to put 1. Where there is b, we are going to put 2. So we are going to have 1 plus 2. This will give us 3. Minus 2 times 1 times 2 will give us 4. So the result for that one is equal to a negative 1. So as you can see, this negative 1 that you have gotten is a real number. So real numbers by definition are all the numbers that you can think of except imaginary numbers. You can have a real number such as 1 over 2. You can have a 5 over 4. All these are real numbers except imaginary numbers such as the square root of negative 1. This is an imaginary number. So in other words, when they are asking you, is star a binary operation on a set of, let's say, real numbers, they are asking you to say, for any two values of a and p that you are going to use, are you always going to get a real number? If yes, then that means to say that is binary on all sets of real numbers. Let's move on. So the next part says, is the operation star commutative? If not, give a counter example. So firstly, we are going to say if a star b is commutative, then that means to say a star b should be equal to b star of a. So there are two ways of doing this. So firstly, you can find your a star of your b. So let's say we have our a plus our b, then we have minus our 2ab, like that. So we can say, let's say our a is equal to 1, our b is equal to 2. So remember, using 1 star of 2, we found this value. When we substitute there, we found a negative 1, which is this one. Then what we are going to do is that we are going to find our b star of a. So b star of our a, this shall be equal to, using the same values, we are just going to interchange them. So here we are going to say our b will be the one that will be equal to 1, then our a will be the one that will be equal to 2. So in other words, so we have our, if we say b star a, for the equation, you maintain the equation like that. If you maintain the equation like that, then all you have to do is interchange the values. So where a is, instead of putting a 1 in the, like the first case, you are going to put just as they are. So b is equal to 1, a is equal to 2. So you have 2 plus, where b is, you are going to put 1. Then we have minus 2, our a is equal to, we have a 2, our b is equal to we have 1. So we are going to have 2 plus 1, that will give us 3, minus 2 times 2 times 1, it will give us a negative 4, which is equal to negative 1. So this is our 1 star 2 for where we have our B star of A. So that means to say we are going to have something like this. So since our A star of B is equal to B star of A, we can say that then they are commutative. So in other words, what we just require to do is that where there is A, you put 1, where there is B, you put 2. Then for the second part, you are going to just interchange them. So you have where there is A, you put a 2, where there is B, you put a 1, which was the opposite, and find the value. If they are the same, then they are commutative, like that. The other approach is where they interchange. Your A star of B is equal to, we have our A plus our B, then we have minus 2AB. The second approach is where they say B star of A. Others might be doing this, should be equal to, you interchange them. So B is there, so B will come there, then we have plus our A will come there. It's more like they are interchanging. Then we have minus our 2, where A is, we are going to have our BA. So in this case, you are able to conclude that they are commutative in the fact that whether you add, let's say we have 3 plus 4. So let's say we have 3 plus 4 and we have a 4 plus 3. So as long as you are adding two numbers, it is the same result. It doesn't matter. Then even when you are multiplying 3 times 4 and a 4 times 3, it is still commutative, meaning to say you will get the same answer even if you interchange the order when you are multiplying like that. So you can conclude from there to say they are commutative if you interchange them like that. Now for this approach, just make sure that when they are interchanging the position, they do not more like carry the sign. So like for example, if you have A minus B, B will come where A is and you will have B, then you will have minus A. It's more like B does not have its own sign. They will just be interchanging like that. So those are the two ways of proving for commutativity. So let's move on to our next question. So for this other one, it says that find the value of 1 star of 2 star of 3 and that, and state whether it star is associative. So we are going to say our A star B is equal to this. So let's first find the value of A star of 2 star of 3. So we are going to first work out what is in the bracket. So we have our 2 star of 3 should be equal to, so this means to say for the equation that is equivalent to our A star of our B should be equal to A plus our B minus 2AB. So where there is A, you are going to put 2. So we have 2 plus our 3 minus 2. Where there is A, you put a 2. That's the meaning. A is equal to 2, B is equal to 3. Then where there is B, you put a 3 like that. So we are going to have 2 plus 3 will give us 5 minus 2 times 2 is 4 times 3, that's 12. Then we are going to have 5 minus 12, that will give us a negative 7. So our 2 star of 3 is equal to negative 7. Then what we are going to have is a 1 star of, where there is 2 star 3 here, we are now going to put the new value, which is our negative 7, should be equal to A plus our B minus our 2AB, like that. So this now changes A star of our B. Where there is A, we put 1. So we are going to have 1. Then where there is B, we are going to put a negative 7 minus 2. Where there is A, put 1. Where there is B, you are going to put a negative 7 like that. This will give us 1 minus 7 will give us negative 6. this times this times this, negative times negative will give us positive. 7 times 2 will give us a 14. Then we are going to get the value which is equivalent to negative 6 plus 14. This will give us 8 like that. So this is what our value of 1 star of our 2 star of 3 is giving us. Then we are going to now evaluate the value of 1 star of 2. Then we have star of 3 as required. So the other part that is required. Knowing that our equation is a star of our b should be equal to a plus our b minus our 2ab, we are going to say where there is, let's first work out what is in the bracket. So we have 1 star of 2. So we are going to have the value where there is a we put 1, where there is b we put 2, minus our 2, where there is a we put 1, where there is b we put 2. So we are going to have 1 plus 2 will give us 3, minus this by this will give us 4. So the result 3 minus 4 will give us a negative 1. So our a star of b is equal to or rather a 1 star of 2. So 1 star of 2 is equal to negative 1. For the equation that is saying that 1 star of 2, then we have star of 3 should be equal to a plus our b minus our 2ab. Where there is 1 star 2, the result is equal to this. So we are going to put negative 1 star of 3 should be equal to a plus b. Then we have minus our 2ab. Where there is 1, we put a. Where there is 3, we put b. So we are going to have something like negative 1 plus our, where there is b, we put 3, minus our 2. Our a value is equal to negative 1. Then our b value is equal to our 3 like that. What we are going to get is that negative 1 plus our 3 will give us positive 2. Then we are going to have plus negative times negative is positive. 2 times 3 will give us 6. We add 2 plus 6 will give us 8. So this is our 1 star of our 2. Then we have star of 3. So therefore we can say since our 1 star of our 2 star of 3 is equal to 1 star of 2 in one bracket, then we have star of 3 which should be equal to 8, then we can conclude to say it is associative. As the test for associativity says that a star of our b star of our c should be equal to our a star of our b star of our c like that. So as long as these are giving you the same answer, then that is associative. So we are given the rational function f of x is equal to this. Sketch its graph indicating its domain and range and all the asymptotes and intercepts. So we have the f of x should be equal to, we have our x plus our 2 over our x minus 2. So we are required to sketch this graph. So remember how we sketch this graph. We are going to find the vertical asymptote. So the vertical asymptote, we get our denominator equated to 0. So x minus 2 is equal to 0 like that. So x is equal to, we take the 2 this side, we are going to have a positive 2. Then we are going to have horizontal asymptote. Horizontal asymptote, if the powers are the same on the leading powers of x, we can just divide them. So we have our x over x should be equal to 1. If your lecturer insists, you can just use the infinite method where you just say your x, you have your x plus your 2 over your x minus 2, which is equal to 1 over your x. 1 over x, you multiply throughout. So this is the limit as x approaches infinite like that. 1, so we have x times 1 over x. So this 1 over x times x, this will give us a 1 plus 2 times 1 over x. This will give us a 2 over x. Then we have 1 over x times x. This x and this x will cancel. We are going to have a 1. Then we have a negative 2 times 1 over x. This will give us 2 times this will give us 2 over x. So we have minus 2 over x. So this is the limit as x approaches infinite. So now as you approach infinite, which you can watch using the other video, so we have a 2 over an infinite value over we have 1 minus 2 over an infinite value. So 1, we are remaining with 1 plus 2 over infinite is equal to 0 over 1 minus 2 over any number over infinite is equal to 0. So we have 1 over 1, which is the same value that we got just by dividing the leading powers. If the powers are the same, you can just do that. But if your lecturer insists, you can do the second part. So we have found our vertical asymptote is equal to 2. Horizontal asymptote is equal to, we have a positive 1. So we can draw the first part of the graph. So this is what we have. Then our horizontal asymptote is at 1. So let's say this is our 1. Then we have our vertical asymptote is at 2, like that. Then we are going to have something like this. So this is what we have. Now what we are going to do is that we are going to first, let's find the x-intercept. Okay, or let's first study the behavior of the graph as we move to the right, as we look at numbers such as a 3 and a 4, like that. Then we are also going to study the behavior at 1, at 0, as we look at this side. So what we are going to have is that for the equation that is saying that our y should be equal to, we have our, so we are going to use, let's study first the behavior of the graph as we look at coordinates that are this side, that are on the left there. So we are going to have, or should I say the right, we have a 3 and a 4. So we are going to have values such as 3 and a 4. We are going to find the corresponding values of y. So we are going to get, where there is x, we put 3. So we are going to have our y should be equal to 3 plus 2 over our 3 minus 2. This is going to give us 5 over 3 plus 2 gives us 5 over 3 minus 2 will give us 1. So the result is equal to 5. When we put a 4, we are going to have y should be equal to 4 plus 2 over, we have a 4 minus 2. This is going to give us a 4 plus 2 will give us 6 over 2, which will give us a 3, like that. Then what we are going to get is that we have, when our x value is equal to 3, we have a value such as a 5, not drawn to scale. So we have a 5, like that. 4 is corresponding with what value was that? The value was 3. So we have a 3 there. We have something like this. So this tells us that as long as you move to the right like that, all these values, they are reducing the value of x at that point, at the value of y, sorry. So that means to say, with this we are able to predict the behavior of the graph. It looks like this. So drawing, it means to say it won't cross that line. So we are going to draw something like this. So it won't be able to also touch the asymptote, but it will more like be approaching the asymptote, like that. So this is our graph, like that. So even this side, it will be moving like that. From there, we are going to study the behavior of the graph on the left of the asymptote, which is our vertical asymptote, this line. So we are going to study the behavior of the graph at that point. So we are going to use values such as 1 and 0, which are on the left. So we are going to have this situation using our 0 and our 1, we are going to have where there is x, we put 0. So this will give us y should be equal to, we have where there is x, we put 0 plus 2 over 0 minus 2. This is going to give us a value of a 2 over negative 2, which is going to give us a negative 1 like that. So we are going to get a negative 1. Then for the second part where there is x, we put 1. We are going to have our y should be equal to, we have a 1 plus 2 over a 1 minus a 2 like that. So this is going to give us a value that is equivalent to, we have y should be equal to 1 plus 2 is 3 over 1 minus 2 is equal to negative 1, which is equal to negative 3 like that. So we have a negative 3 like that. So what we are going to have is that we look at our points. So 0 is corresponding with negative 1. So 0 comma negative 1 is a point that is somewhere here. Then we have a 1 is corresponding with a negative 3. So extending this a bit, we have a negative 3 there. So what we have is, we have 0 comma negative 3 is here. We also have a 1 comma negative 3 is there. So that means to say our graph is generally going like that. But let's add an additional point. Let me create more space. So instead of us using negative 1, let's just find where it crosses the x-axis. So at this point, we know that x-intercept y is equal to 0. So we are going to get, where there is y, we are going to put a 0. So we have where there is y, we put 0 should be equal to x plus a 2 over our x minus 2. Then we are going to cross multiply our x minus 2 times 0. Since there is 0, it will be 0. We are going to have x plus a 2. We take the 2 the other side. So we are going to have a negative 2 should be equal to x. So this is our x-intercept. So our x-intercept is at negative 2. So we are going to go at negative 2 like that. So we have 3 sets of points that we are going to use. So that means to say, the more you go this side, the more the value increases. So we are going to join them to have something like this. Yeah. So it will be able to follow the asymptote like that, but it won't be able to touch it like that. So this is how we draw, having all the intercepts. So this is our graph. This is the way it's looking. All the points at which it's passing, it's not touching the asymptotes like that. So this is how we graph that. Let's look at our next problem. So that's the answer for that. So we have proved that the square root of 2 is an irrational number. So to answer this question, you're going to begin to say, suppose the square root of 2 is a rational number. So you're proving by contradiction, rational number. So these statements are important. That means to say it can be expressed in the form a over b, where our b is not equal to 0, and also a and b are members of integers like that. So these statements, integers are just numbers, negatives and positives. They do not include fractions. So now what this means is that if the square root of 2 is a rational number, it can be expressed in the form a over b. Therefore, we are now allowed to do the square root of 2 should be equal to a over b. So first, come up with a statement, then you are free to do this. Then what you are going to have is that we have the square root of 2 is equal to a over b. What we are going to do is that we are going to square both sides to remove the square root. Then we are going to have our 2 should be equal to, we have the square distributes, we are going to have a squared over our b squared like that. Then we are going to cross multiply. We are going to have 2 times b squared. It will give us 2b squared should be equal to our a squared. Now what does this mean? Let's say if you have the number 8. 8 is the same as having 2 times our 4 like that. So whatever you have, as long as you have a certain number outside multiplying. Now in this case we have our 2. Where there is 4 we have our 2a. So as long as you have a number in front that tells you to say it is equal to more like 8, it is a multiple of 8 like that. So that means to say whatever number you have in front there, that tells you to say that that number is a factor of whatever number is there. So we are going to say that a squared has a factor of 2. Then that means if a squared has got a factor of 2, that means a has a factor of 2. Then that means to say we can represent our a to be equal to 2 times some constant k. Same idea that we were using. If we have 8, 8 is the same as 2 times 4. So where there is 4, we have more like put k. So a is the same as 2 times a certain number if you multiply. Then that means for the equation that is equal to 2b squared is equal to a squared, where there is a. Now remember, that means a has got a factor. So a has got a factor of 2 like that. So a has got a factor of 2. So that means to say we have said that a rational number is a number that can be expressed in the form a over b, where b is not equal to 0, and a and b. So a and b do not have common factors. So they should not have common factors. If they do, then that means to say they are not rational numbers. Therefore, they must be irrational. So, getting the value, this a is equal to 2k. We are going to put, where there is a, we put 2k. So, 2b squared should be equal to, we have, where there is a, we put our 2k. Then we have squared. This gives us 2b squared should be equal to, we have 2 squared gives us 4. K squared is like that. Then what we are going to have is, let's divide over 2 over 2. This will give us our b squared should be equal to, so dividing 4 divided by 2 gives us 2k squared like that. So we can say already b has got a common factor of 2. So we can say b squared has a common factor of 2. That means to say b has a factor of 2. So if the square has got a factor, then that means to say even the individual letter has got a factor, as a factor of 2. Now, as we can see, already a has a factor of 2. So you can write this statement, but don't write this. A has a factor of our 2. Then also b has a factor of 2 as well. So that means to say 2 is a common factor. We can conclude to say then it is not rational. Therefore, it must be irrational. So if it is not rational, it means to say it is irrational like that. So that is how we solve that one. Oh, we forgot to find the domain and the range. So the domain, let's begin with our domain. So domain are the x values that can be used. So as you can see, this graph, the only coordinate in terms of the x that it is not touching is this line. So we are going to say that the domain is made up of x values such that x is a member of real numbers, such that x is not equal to the 2 that is here. So x should not just touch the 2. In interval notation, this can be written as, including all the values, it will be from negative infinity to 2, this open brackets to show that 2 is not included, union of from 2 to positive infinity. So you can write the domain like this or like this, but if they tell you the interval notation, you have to represent it like that. Then the range are all the values of y that you are able to get. So as you can see, the only value of y that is not being touched is this line, and this line is at 1 like that. Is at y should be equal to 1 like that. So our range means to say we are going to have, the range is made up of our y values, such that our y values are a member of real numbers, such that y should not be equal to 1. So this is the only value of y that is not touched. So range is equal to y such that y is not equal to, or y is a member of all real numbers. It is including all the numbers which are real numbers except 1. In interval notation, this may be represented as from negative infinity, so meaning to say from the down here, from the down until you reach your positive 1. So we have from the down until you reach your positive 1, close brackets to show that positive 1 is not included, union of from now positive 1 not included to all the values that are up there. We are going to have 1 comma a positive infinite. So if they don't restrict you, you can write it like this or like this. Let's look at our next problem. So we have this one, let f of x be equal to, so we have our f of x be equal to, we have our x plus 1 over our x minus 1, and g of x should be equal to the square root of our x like that. Then we are told find g f of x and determine the domain. So to find our f g of x and determine the domain, so we are going to say our g, in fact g f of our x should be equal to, we have the function, this is the same as having the function of g, where there is x, puts the function of f of x, that's the meaning. So we have our g of x is equal to the square root of our, where there is x, we are going to put our f of x. Now replace, we have the square root of our f of x is equal to x plus 1 over our x minus our 1 like that. So this is our gf of our x like that. Therefore, we are going to say that, so if we have the square root, what we just say is that our x plus 1, whatever is inside, set it greater or equal to 0 like that. But remember, x cannot be equal to 1 if that is the case, because if we put 1 minus 1 on the denominator, we don't want a 0 on the denominator. So whatever makes the denominator to be equal to 0, that means to say you should set it not equal to that. But we are still going to use it to find our critical values. The critical values are our zeros of the equation. So to find our critical values, we are going to say x plus 1 is equal to 0, or we are going to have our x minus 1 is equal to 0. We take this value this side, we are going to have our x is equal to negative 1, then we are going to have our x is equal to positive 1 like that. When we take this value that side, so these are the values we are going to use. Let's come up with an interval. So we are going to have a negative 1, a positive 1. Then all the values that are this side, you will find that they are less than negative 1. They could be negative 2, negative 3. So we can say x is less than negative 1. All the values that are this side. Then all the values that are this side, we could have a 2, we could have a 3. All of them are greater than 1. So we can say x should be greater than 1 like that. Then from here, all the values. So here we could have a 0. We could have a 0.5 and all that. All these values are such that they are greater than a negative 1 but less than 1 like that. So this is what we have. So with this, let's come up with our table. So we are going to put our intervals. So we have our x is less than negative 1. Then we have our negative 1 less x less 1. Then our last one is our x is greater than positive 1 like that. So we are going to have, if x is less than negative 1, it means to say x at this point can be equal to negative 2 if that's the value that is less than negative 1. If you want negative 3 is okay. So from negative 1 to 1, we could have a value such as a 0. Then if x is greater than 1, it means to say x can be equal to positive 2. Then we have factors. So our factors, we are going to have something like this. So we have our x plus 1 and our x minus 1. So we are going to say x plus 1 and our x minus 1. When these two divide, we are going to form our quotient like that. So when we put our negative 2 here, we are going to have negative 2 plus 1. This will give us a negative 1. So we are going to write the sign negative. When we get this negative 2, we put where x is, we are going to have negative 2 minus 1, which is negative 3, which by the sign convention, we are going to put negative. Negative divided by negative will give us a positive. Then we are here, if we put 0 here, it will be 0 plus 1, which is a positive 1. So we are going to say positive. If we put 0 here, it will be 0 minus 1, which is equal to negative 1. In this case, the sign will be equal to a negative like that. Positive divided by negative, this will give us a negative like that. Then we are going to get this 2, put it there. We are going to have a 2 plus 1. This will give us 3. So the sign there will be equal to a positive like that. So we are going to have a positive like that. If we get the 2, we put it here, it will be 2 minus 1, which will be equal to a positive 1. So the sign there will be equal to a positive value like that. Positive divided by positive, this will give us a positive sign like that. So this is what we have. Now remember, we set the whatever was inside to be greater than 0. We had our x plus 1 over our x minus 1 should be greater than or equal to 0. So we are going to pick the side that is greater than 0, in which case the positive is the one that is greater than 0. So we are going to take the interval. It is saying that our x should be less than our negative 1. Now in this case, since there is less than or equal to, we are going to add that. Then we are going to say or. We are going to have another positive. It's saying that x should be greater than 1. Now remember, we are not going to say greater than or equal to for this one, because if we do that, we mean to say x can be equal to 1 as well, which means to say if we put 1 here, we are going to have 1 minus 1 on the denominator, which is going to give us 0. Now we don't want the denominator to be equal to 0, which will produce undefined, so we don't include that. Any value that will cause undefined, we don't include it. So this is what we have. So in interval notation, if x is less than negative 1, the smallest value will be a negative infinity to a negative 1. So less than or equal to means to say you can include 1. then or means union, then we are going to have 1. If x is greater than 1, the smallest would be 1 not included, comma, the highest could be a positive infinite, like that. So this is our interval for that one. Let's look at our next question. So we have, using the associative and distributive properties of union and intersection sets, show that A union of B is equal to A intersection of B, and that. So what we are going to have is that we have our A intersection, A union of B should be equal to, we have our A intersection of B union of our A intersection of our B complement union of our A complement intersection of our B, like that. So we are required, so we are going to pick the side that is more complex. So we are going to pick this side, which is our A intersection of B. So this part, we are going to take it to the easier part there. So we have our A intersection of B, like that, union of, we have our A intersection of our B complement, then we have our union of our A complement intersection of our B. So using the associative property, so associative, think of it as if you are factorizing. So just taking it from here, what we are going to have is A is common, so we are going to write our A. Intersection is common, we write intersection. Then whatever is not common, we leave it. Then we are going to have open brackets, B is not common. Then we combine it with a union that is not common, B complements, like that. So this is what we have. Then we have the union of the remaining is our A complement intersection of our B, like that. So now after we do that, we are going to say this is A intersection of B union of B. So B union of B complement is equal to the universal. So if you are going to say B union of B complement, combining what is in B and what is not in B forms the universal set. So then what are we going to have? We have union, we have our union of, we have our A complement intersection of B. Now A intersection with a universal, the only thing in common, A and the universal, let's say we have the set A, the universal is this one. So A intersection with a universal is A, because that's the thing that they have in common. So we are going to write our A intersection of with the universal is equal to A, like that. Then we have in union of, we have our A complement intersection of our B. From there, we are going to apply the distributive law. The distributive rule applies the concept of expanding. So we are going to multiply A times A complement. So now we have a union here. So we are going to have A union of times A complement. Then A union of, it's more like you're opening the bracket. Since the intersection is inside, it will come there. Then we have our A union times our B, like that. Now remember, same case, A union of A complement is also equal to the universal intersection of our A union of our B. Likewise, the only thing in common, if we have our A and our B, then outside we have the universal. If we are to find the common set, is that with the universal, is that the combined sets will be the universal, or will be the intersection. So the answer is A union of B. We can say hence shown. Let's look at our next question. For this other one, we have been told let alpha and beta be roots of a quadratic equation. Find the quadratic equation whose roots are these without calculating alpha and beta. So what we are going to do is that we are going to say the root of a quadratic equation, the formula is that we have our x squared minus x, then we have the sum of roots, then we have plus our products of roots. In fact, products of new roots. like that. So this is the formula. So therefore we need to first find the sum and the product. So what we are going to have is, let's first find our sum for this equation, which is our 3x squared plus our 2x plus our 5 should be equal to 0. So what we are going to have is that when we add our sum for these, we are going to have sum of roots, which is alpha plus beta, is given by the formula negative p over a, like that. So here we have our a, we have our b, we have our c. Then our b is equal to 2, so we have a negative 2 like that over our a, which is equal to a positive 3 like that. Then what we have on the second part is the product. So the product should be equal to, which is alpha times beta. You multiply the roots, should be equal to, we are going to have a c over a. So c here is 5, c over a, which will give us a 5 over our a is 3 like that. Then what we are going to get is the fact that now to find the new sum, remember what we have been given. We have been given the roots as alpha 1 over alpha squared. So the roots are 1 over alpha squared and 1 over beta squared. So to find the new sum, we add them. We are going to say 1 over alpha squared plus 1 over our beta squared. This will give us common denominator. We take both of them, alpha squared, beta squared. Then what we are going to have is this multiplies this, so we can have alpha squared plus this multiplies that. As long as you have taken both of them as the common denominator, you can do that. So we have beta squared like that. Now what we are going to do is that we know to say alpha squared plus beta squared. If you haven't watched the video, watch it. I'll be just comment in the section. So we have alpha squared, or alpha plus beta squared minus 2 alpha beta. This is the identity for this one. So we are going to have our alpha plus our beta squared minus 2 alpha beta. Then we have, this is the same as alpha squared, alpha beta, both of them have got squared, so it can be written like this. So the aim of this is for us to be able to now just add normally our alpha plus beta. We have found the sum of the roots to be equal to, negative 2 over 3. So we are going to put a negative 2 over a 3. Then we have squared minus 2. Alpha times beta is equal to 5 over 3. So we are going to put a times 5 over 3 like that. Then this value we divide over the product. We have found it to be 5 over 3 squared like that. So this will give us a value of negative 2 squared will give us 4 over 3 squared will give us a 9. So we are going to have 9 minus 2 by 5, it will give us 10 over our 3 like that. Then down here we have 5 squared, we are going to have 25 over 3 squared will give us 9. So what we are going to have is we are going to get a 4 over 9 minus 10 over 3 divided by 25 over 9 like that. Common denominator here will give us a 9. Then 9 divided by 9 is 1 times 4, it will be 4. 9 divided by 3 is 3 times 10, which is going to give us a 30. Then division converts to multiplication. We have a 9 will go on top over a 25. So this and this will cancel. 4 minus 30 will give us negative 26 over 25. So this is the sum of the roots Then our product of roots, product of new roots will be equal to, we have 1 over alpha squared times 1 over beta squared. This will be equal to 1 over alpha squared beta squared, which can be written as 1 over alpha beta squared, like that. Then what we are going to get is a 1 over alpha beta. Alpha by beta is equivalent to 5 over 3. So we are going to write 5 over our 3. Then we have squared outside. So this is going to give us 1 over 5 squared is equal to 25 over 3 squared will give us 9. So division, how it works, if you have a number, you can just throw this up there. So we are going to have a 9 over 25. If you want, you can do 1 divide by 25 over 9 and convert it to multiplication. But basically, that's how it works. So this is the product of the roots. So after we have done that, we can now be able to, let's just write our sum. 1 over alpha squared plus 1 over beta squared is equal to negative 26 over 25, if I'm not mistaken. Negative 26 over 25. So we are going to find the new equation. So new equation should be equal to, we have our x squared minus our x, then we have the sum plus our product. So we have our x squared minus our x. Our sum is equal to, we have the sum to be equal to negative 26 over 25. Then we have plus the product. Product is equal to, so when we multiplied our roots, we had a 9 over a 25 should be equal to a 0, like that. So this will give us x squared plus negative times negative is plus 26. 26 times x, it's 26x over 25. Then we have plus our 9 over 25 should be equal to 0. So we are just going to get rid of this 25 by multiplying with 25 throughout. If you want, you can find the common denominator, then cross multiply, but this is a straightforward thing. So 25 by x squared, it's 25 x squared. 25 and this one and this one will cancel. So we are going to have 26x. This 25 and this 25 will cancel to give us 9 should be equal to 0. So that's the equation. Let's solve this one. So solve the given radical function inequality. So we have the square root of our 2 minus the square root of our x plus 6 less than or equal to negative the square root of our x, like that. So now, before you answer this one, you have to test domain. So test domain. You don't know whether there is a certain value that can satisfy this condition. So how you test the domain, we are going to set this greater than or equal to 0 since it's in a square root. So we are going to say 6 plus our x plus 6 should be greater than or equal to 0. You take the 6 there, you are going to have your x should be greater than or equal to a negative 6, like that. Then what you are going to have is that when you do that, you are going to test this value, put it there. So let's say our x is equal to negative 6. Since we are saying that x should be greater than or equal to negative 6, it means to say negative 6 can be used. So you are going to get your negative 6 and put it there. So we have for the equation that is square root of 2 minus the x plus 6 less than or equal to negative the root of our x. Let's try this value. If we put where x is, we put negative 6, we are going to have the square root of 2 minus, open brackets, where there is x, we are going to have this plus 6. Then we are going to have the negative 6. So immediately you have a negative inside the root like that. Then just conclude to say this is false. You are going to also now test the domain for this one where we have our x. So where there is x, testing the domain for whatever x, we are going to say greater than or equal to 0, meaning to say our x can be equal to 0. If we get our 0, we put it there. We are going to have our square root of our 2. Then we have minus the square root of our x plus 6. Then we have our less than or equal to negative the root of our x. This will give us the root of 2 minus the square root of, where there is x, we put 6 plus, we put 0 plus 6, less than or equal to negative the root of, we have our 0. What we are going to have is the square root of 2, then we have minus the root of 0 plus 6 is 6, less than or equal to, the square root of 0 is 0 times negative 1 is just 0. So this is what we have. Now we can take this value the other side. This will be equal to, the square root of 2 should be less than or equal to, if we take the other value greater than 6. We know to say the square root of 2 is less than this, which is, since this is pointing to where 6 is, then we can say this is a true statement. So already this proves that among your solutions, your x is greater than or equal to 0 is true. So your x is greater than or equal to 0 is true. When you verify that, it's possible that sometimes none of them are working. But since that is working, that is part of the solution. Now we are going to get our equation, which is saying that the root of our 2 minus the x plus 6 should be less than or equal to the root of our x. So what we are going to do is we are going to take this value this side and this one this side to make it easier. So we are going to have the root of 2 minus, if this comes the other side, minus the root of our x should be less than or equal to, if this value goes the other side, this sign will change to positive, root of our x plus our 6, like that. Then from here we can square both sides. So squaring both sides, we are going to have something like, this is the same as having root of 2 minus the root of x 2 times times the root of 2 minus the root of x. So this should be equal to, this and this cancels, we are going to have our x plus 6, like that. So this value multiplies everything that is there. So we have the root of 2, open brackets, root of 2 minus the root of our x. Then this value multiplies everything. So we are going to have negative root of x times the root of 2 minus the root of our x, like that, should be equal to x plus our 6, like that. So root 2 times root 2 will be equal to the root of 4. Just multiply what is inside. We have minus root 2 times the root of x will be what is inside. We are going to have 2x, like that. Then we have minus negative root x by 2 will give us, open brackets, we have the 2x. Then we have root of x times the root of x. It will first change the sign, positive. Then we have x by x, it will be x squared. So we have x squared should be equal to x plus 6. So this will give us root of 4 is equal to 2 minus, so if they are the same in the roots, just add or subtract whatever is outside. So negative 1 minus 1 is a 2. Then we have the root of 2x, like that. Then we have this and this cancels, so we have plus our x should be equal to our x plus 6, like that. Okay. The sign. So it's supposed to be less than. So not forgetting that was a mistake. So what we have is this. So take the x, this other side, it will be, we have a 2 minus, in fact, let's take all the values except this one or the other side. So we are going to have something that is going to look like this. So the 2, when it goes the other side and this x goes the other side, we're going to remain with our negative of 2 square root of our 2x less than or equal to, we have our x, then this comes there, we have minus x, if it goes there, plus 6, then we have minus our 2 like that. So we are going to have a negative 2 root of our 2x less than or equal to, x minus x is 0, 6 minus 2 is 4 like that. So this is what we have. Okay, so from the look of things, we have been solving so this is the correct answer for the wrong question. So the question is saying that we should have a negative x there. Now here we forgot the negative, not here. So we have the negative there. So when it goes the other side, it shall be positive. The square, we are going to have plus, just changing the sign, we have plus. This is going to give us 4, still the same, but the sign is the one that will change. So this is what we are going to have, like that. When it goes that side, so we have a positive 2. So when those values goes the other side, everything now is going to be the same. So we have a positive 2 like that. Then what we are going to have is 2 roots of our 2x less than or equal to 4. Divides 2. We are going to have the root of 2x. Root of our 2x should be less than or 4 divided by 2 is 2. From here, we are going to square both sides. This will give us this and this cancels. So we have a 2x less than or equal to a 4 like that. Then we divide over 2 over 2. Then we are going to have a x should be less than or equal to 2. Then we also had our x should be greater than or equal to 0. Now if this is the case, we can just have an interval. Since x is common, we have a 0 there, and says 0 should be less than or equal to x, which is this first part of the problem. Then we also have, let me reverse it so that you can even see it. 0 is less than or equal to x. So we have written this, but at the same time, x is less than or equal to 2. So this is the answer that is expected for that problem. Let us solve this one. So solve for x and y given this. So we have our x over our 1 plus I. Then we have minus y over our 2 minus I should be equal to, we have our 1 minus 5i over, we have our 3 minus our 2i like that. So what we are going to do is that we are going to conjugate. So just immediately you see this, just conjugate from there. Do not find the common denominator first. So we are going to have our x over our 1 plus I conjugate this. So we are going to have our 1, the conjugate of 1 plus I is 1 minus I like that. Then we have 1 minus I like that. Then we have minus y. Then we are going to have over our 2 minus I like that. We are going to find the conjugate of this is 2 plus our I like that. Then even on top, our 2 plus our I like that should be equal to. So here we are just going to write, due to space, 2 minus 5 minus that over 3 minus 2i. So we are going to get x times 1, it will be x. X times negative I, it will be negative xi over. So if you have the conjugate, you can just multiply first number with first number if you want to expand. But you can, the simple way, first number with first number, it's 1. 1 times 1, it's 1. I times I, it will be negative. Positive times negative, it's negative. Then I times I is I squared. Then we are going to have minus. We have our y times 2, it will be 2y. Then we have minus y times I, it will be yi like that. Then we have over 2 times 2 will give us 4. I times I will give us I squared. Negative times positive, it will give us a negative. So we are going to have something like this, should be equal to, we have our 1 minus our 5i like that, over 3 minus 2i. Let's conjugate the denominator by multiplying. Okay, let's reduce it first. So we have our x minus our xi over, we have 1, I squared is equal to negative 1 like that, minus our 2y minus our yi over, we have 4, I squared is equal to negative 1 like that, should be equal to, we have our 1 minus 5i, then over 3 minus 2i. So the conjugate of this one will be our 3 plus our 2i like that. Then here we have a 3 plus 2i as well. So this is going to give us, we have here we have our x minus our xi over 1. This times this will be plus 1. Then we have minus our 2y minus our yi. Then we have divide by, we have our 4. Negative by negative, it's positive 1 like that. Then this should be equal to, so multiplying. Now this is not a conjugate on top, so we have to multiply. So this one multiplies everything. So we have 1 times 3 plus 2i. Then we have minus our 5i, multiplies everything. So we have a 3 plus our 2i like that. So we have over, conjugate first number with first number, 3 by 3 is 9. Last number with last number, negative by positive is negative. 2 by 2 is 4. I times I is I squared like that. So what we are going to have is our x minus our xi. X minus our xi over 1 plus 1 is 2. Then we have minus our 2y minus yi over 4 plus 1, that gives us a 5, should be equal to 1 times 3 is 3, 1 times 2 is 2i. Then we have minus 5 times 3 will give us a 15i. Then 5 times 2 will give us a negative 10i like that. Then we have over 10i. So 5 by 2i, it will be 2i squared like that. What else do we have? Okay, so we have over 9 minus 4, I squared is equal to negative 1. So we can do that. So we can now begin even separating. So we have our x over 2. So the 2 divides everything. Then we have minus our xi over 2 like that. Minus, even the 2y will face a similar situation. Minus our yi over our 5 like that, should be equal to, we have a 3. 2i plus minus 15i, it will be minus 13i. Then I squared will give us, so we have minus 10. I squared will give us a negative 1 like that. Then we have over 9. Negative by negative, it will be positive 4 like that. So this will give us, let's just collect the like terms, the ones that have got the real parts, the ones without I. So we are going to have our x over 2 minus our 2y over our 5 like that. Then we have minus our xi over 2 minus our yi over 5 like that, should be equal to, what we have is a 3 minus 13i. Negative by negative is positive 10 like that, over 9 plus 4 will give us a 13. So we are going to have our x over 2 minus our 2y over 5 minus our xi over 2 minus our yi over 5. This will give us a value 3 plus 10, this will give us 13 minus 13i over 13. So this is going to have x over 2 minus our 2y over 5 minus our xi over 2 minus our yi over 5 should be equal to, we split these. So this is the same as 13 over the denominator minus 13i over the denominator, like that. So we are going to have our x over 2 minus our 2y over 5 minus our xi over 2 minus our yi over 5 should be equal to 13 divided by 13 will give us 1. 13 divided by 13 will give us 1. Now we are going to remain with our negative I, like that. So we are going to equate the real with the real, the real with the real. So even this is a real, then this is the imaginary, then also this is the imaginary. So we are going to, as long as it has got I. So the real part, it will be x over 2 minus 2y over 5 should be equal to, we have a positive 1, like that. So what we are going to have is that the common denominator here is the number that can act as our common denominator is a 10. So 10 divided by 2 is 5. 5 times x, it will be 5x. 10 divided by 5 is 2 times 2, it will give us negative 4y. Since there is a negative, should be equal to 1. From here we are going to cross multiply. So we are going to have 1 times this. 1 doesn't change anything, so it will return. So we have a 5x minus our 4y should be equal to 10 by 1, it will be 10, like that. Then what we are going to have is that, let's equate the imaginary. So we have our xi over 2 minus our yi over 5 should be equal to negative I, like that. So same approach, we are going to find common denominator is 10. What we are remaining with is 10 divided by 2 is 5 times that, it will give us 5xi. 10 divided by 5 is 2 times that, it will give us minus 2yi should be equal to negative I, like that. We are going to cross multiply. This will give us a value. 1 doesn't change anything, so it will return 5xi minus a 2yi should be equal to, we have a 10i, like that. From here we are going to divide our I throughout so that we cancel it, our I throughout. So we are going to find that it will cancel. We are going to have our 5 x minus our 2y should be equal to positive 10, like that. Then we are going to solve these equations simultaneously. This will give us a 5x minus 4y should be equal to 10. Then this other one, we have 5x minus 2y should be equal to 10. So 5 and 5 is the same, so we are going to attach a negative so that 5 minus 5 can cancel. 5 minus 5 is 0. Then we have our negative 4, so we have negative 4y minus, we have a negative 2y. This will give us a negative 4y. Then we have plus our 2y, which will give us a negative 2y. So we are going to have a negative 2y. Then our 10 minus 10, this will give us 0. So therefore, over negative 2 over negative 2, our y should be equal to 0. Looking at the other one, getting any of the two equations, let's get this. So getting any of the two equations, 5x minus 2y. So 5x minus 2y should be equal to, we have a 10. So remember, when y is equal to 0, we are going to have a 5x minus 2, where there is y, we put 0, should be equal to 10. So we have a 5 minus 0. 0 doesn't change anything, so 5x is equal to 10 over our 5 over our 5. Our x value is equal to positive 2. So we have found our y to be equal to 0 and our x to be equal to 2. That's how we solve that one. For E, we are told show that the function f defined by f of x is equal to this is a bijection on R. On 2, y is a member of R such that y is not equal to 2. So we are going to begin. So we are going to first, so we have our y should be equal to 2x over our x minus 1 if you want it's f of x. Now what we are going to have is that we are going to test for 1 to 1, which is also known whether or not if it is injective. So we are going to test for whether or not it's injective or not, or rather 1 to 1. So the test for a 1 to 1 is that f of a is equal to f of b, which is the same as a is equal to b. So this is the test for 1 to 1. So we are going to say f of a should be equal to, where there is x in this equation we are going to put 2, or we are going to put a, over where there is x we put a minus 1, like that. Then we put our f of b on the other hand should be equal to, where there is x we are going to put b. So it will be a 2b over where there is x down here we have a b minus 1, like that. Then we have said that f of a should be equal to f of b. Then we are going to equate them. So we have f of a is equal to a over 2a over our a minus 1 should be equal to f of b is equal to 2b over our b minus 1, like that. What we are going to have is cross multiply. So we are going to have our 2a open brackets b minus 1 should be equal to, we multiply 2b, we multiply with this, which is our a minus 1, like that. 2a by b, this will give us our 2ab. 2a by 1, it will be minus 2a. 2b times a, it will be equal to 2ab. 2b by 1, it will be minus our 2b, like that. Then what we are going to get is, let's take this value this side. So we are going to have 2ab minus 2ab minus our 2a should be equal to negative 2b, like that. So this minus this is 0, which will just give us a 0. It's okay if we don't write the 0. Minus our 2a should be equal to minus our 2b. Let's divide by negative 2, negative 2. We are going to find that our a is equal to b, like that. So our a is equal to our b, like that. Then we are going to test for surjectivity. So surjectivity means for every value of y there is a unique value of x. So we are going to have, or rather there is an x value. So we are going to have, so surjectivity simply means if we have, let's say, a, b, c, if we have d, e, f, for every member of x has got its own member of y. That's the meaning of surjectivity. Each member has got a y value. That's the meaning. Now if we have a, b, c, let's say d, we have e, f, g. Then if these have got a value, but there is a value in the set of y that does not have a member, then it's not surjective, like that. Now we are going to say for y, we know that y is equal to 2x over our x minus 1. So this is going to give us 2x minus that. We are going to just find the inverse. Find the inverse. So we are going to have y, open brackets, x minus 1 should be equal to 2x. X times y, it will be xy. Y times negative 1 is negative y, should be equal to 2x. Let's make x the subject of a formula. So we are going to have our xy minus our 2x should be equal to y. When it goes that side, it will be positive y. factorize the x. So we are going to have x open brackets y minus 2 should be equal to y. We divide over our y minus 2 over our y minus 2. This is going to give us our x value is equal to y over our y minus 2, like that. So now you will begin to say it is surjective, meaning to say each value of x has got a value of y. That's the meaning. So it is surjective for the restriction is that y is not equal to a 0. So y is not equal to, sorry, not 0. Y is not equal to 2, because that's the only value of y that cannot be produced by any x value. So surjective means for every value of y there is an x value that can produce it. So in this case, even we have been told that y should not be equal to 0, meaning to say as long as these other values can be produced by an x value. Like for example, if let's say our y is equal to 0, this y is equal to 0, x is equal to, where there is y, we are going to say 0 over 0 minus 2, 0 over any number is equal to 0. So that there exists when y is equal to 0, x is equal to 0. When let's say we say y is equal to 1, y is equal to 1 can be produced by x is equal to 1 over, where there is y, we are going to put 1 minus 2. So 1 minus 2 gives us, so we have 1 minus 2 is negative 1, which is going to give us negative 1. So when y is equal to 1, my x value is equal to negative 1. So in other words, for every value of y, there exists a value of x. Now the 2, if we put 2 here, we are going to find that for x is equal to y over y minus 2, this is going to give us x is equal to, where there is y, we are going to have 2 over 2 minus 2. Already this falls apart to say 2 over 0. We'll cross multiply, you are going to find 0 times x is 0 is equal to 2, which is false. So therefore this is surjective if and only if y is not equal to 0. So you can now conclude to say it is surjective and it is also it is also injective, or it is one-to-one. So a bijection means it is both injective and surjective. So that means to say it is a bijection. So considering that y should not be equal to 0, then it is a bijection, or it is bijective, meaning it's both. Let's look at our next problem. This other one says use the rational root theorem to solve x to the power 3 minus 4x to the power 2 plus our 8. So we are going to test a certain value. So use the rational root theorem to solve. So to solve using the rational root theorem, we are going to say the possible roots possible rational roots are, we are going to have our a0 over our an. So the roots of a0, which is the same as p over q, should be equal to p. A0 is the one without x. So the factors of 8 are such that we have plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. So these are the possible roots divided by the possible roots of q. Q is the, or rather an is the leading power, the one with the highest power. The coefficient is 1, meaning to say the roots are just plus or minus 1. So the possible roots are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. So these are the possible values. So we just need to find one. So just looking at this problem where we have x cubed minus our 4x squared plus 8 If we replace a certain value here, it should give us 0 as our remainder. Therefore, you cannot even use 1 because already 1 minus 4 is 3 plus that, which will be a waste of time. Let's try a 2. So if we put 2 to the power 3 here, it will be 2 to the power 3 minus 4. Where there is x, we put 2 squared plus our 8. This will give us 2 to the power 3 is 8 minus 4. 2 to the power 2 is 4. Then we have plus our 8 like that. So this is going to give us 8. 4 by 4, it will give us 16. Then we have plus 8. 8 plus 8 is positive 16 minus 16. So this is 0. So already 2 is a factor. So using this, we are going to now use the synthetic division. So the powers are from x to the power 3, x to the power 2, x to the power 1, and x to the power of 0. Then we have the factor that we have used is a 2. Then we are going to be multiplying here, adding. So the power of x to the power 3, the coefficient on x to the power 3 is 1. The coefficient on x to the power 2 is negative 4. Should be negative 4. Then the coefficient of x to the power 0 is 0, or x to the power 1 is 0. Then we have a positive 8 like that. Then what we are going to have is we are going to drop the first number 1, multiply 2 times 1. This will give us a 2, add negative 4 plus 2. This will give us a value that is equivalent to, so negative 4 plus 2 will give us a negative 2. Multiply 2 times negative 2. This will give us a negative 4 like that. 0 plus negative 4 will be a negative 4. Then 2 times negative 4 will be equal to negative 8 like that. 8 plus negative 8, so 8 plus negative 8. This will be the same as 8 minus 8, which is equal to 0 like that. Then what we have is for the equation that is equivalent to, we have x to the power of 3 minus 4x to the power of 2. Then we have plus 8. Then should be equal to, we have the first factor. If we said that x is equal to 2, it means when it comes back here, we are going to have x is equal to negative x minus 2. X minus 2. So we are going to put x minus 2. Then we are going to have times. So the coefficient is 1, so it will be x to the power 2 like that, minus our 2. Then we are going to have our x minus our 4. So we are reducing the powers. You can watch the previous video on polynomials. So we reduce the powers from 3 to 2 and all that. So the next stage that we are going to do is that we are going to now work out with this. So our x squared minus our 2x minus our 4. So solving this using the quadratic formula, since it can't be factorized, we are going to have our x is equal to negative b plus or minus the square root of our b squared minus 4ac over our 2a like that. So we have our x should be equal to negative, our b is equal to negative 2 plus or minus the square root of our b is negative 2 squared. Then we have minus our 4, our a is equal to 1, our c is equal to negative 4 like that. This will give us a value over our 2, our a is equal to positive 1 like that. So our x should be equal to negative by negative, it's positive 2 plus or minus the square root of negative 2 squared is 4. Then we are going to have negative by negative, it will be positive. 4 by 4 will be equal to 16. Then over, we are going to have a positive 2 like that. So x is equal to 2 plus or minus the square root of 4 plus 16 will give us 20 over a 2 like that. Then we are going to have x should be equal to the square root of 20 is the same as, so we have plus or minus the square root of 20 is the same as a 4 times 5 over 2. So we are going to have our x plus or x should be equal to 2 plus or minus. So this is the same as square root of 4 times the square root of 5 according to the properties of radicals over 2. So we are going to have our x should be equal to 2 plus or minus the square root of 4 is 2 times the square root of 5 over 2. Factorize the 2. We are going to have x is equal to, if you want you can just divide on both numbers, plus or minus 2 over 2 square root of a 5 like that. What we are going to have is x is equal to 2 divided by 2 is 1 plus or minus the square root of our 5 like that. So it's either x is equal to 1 plus our square root of 5 or x is equal to 1 minus the square root of our 5 like that. And also x is equal to 2. So we have found 3 values of x, which is expected of a polynomial with a degree 3. So we have rationalized the denominator. We are going to have something like this. So we have 1 over the square root of our 2 plus 1. Then we multiply this by the square root of our 3 minus 1 like that. So this is going to give us a value that is equivalent to. So we are going to rationalize the denominator. So we are going to split this. So this is the same as 1 over the root of 2 plus 1 times 1 over the root of 3 minus 1 like that. So this is going to be 1 over the root of our 2 plus 1. We multiply. So the conjugate of this is the root of our 2 minus 1 times the root of our 2 minus 1. Then we have times 1 over the root of our 3 minus 1. So the conjugate of this number is equivalent to, we are going to have the root of our 3 plus 1 like that. Even on top, we are going to have the root of 3 plus our 1 like that. So we are going to have the root of 2 times the root of 1. This will give us, 1 doesn't change anything, so this will come. So it will be the root of our 2. 1 times negative 1, it will be negative 1 over, what we are going to have is, if you have the conjugate, just multiply first number with first number. So we are going to have root of 2 times root of 2. It will be the root of, multiply what is inside, 4. Last number with last number. So it will be 1 times negative 1 is negative 1 like that. Then we have times, we are going to have the root of 3. So root 3 times 1 is root 3 plus 1 times 1, it's still 1. So this is a plus over, we are going to have the root of 3, first number with first number as long as it's a conjugate. So we are going to have the root of 9. 3 times 3 is 9. Negative by positive, it's negative. 1 by 1 is 1 like that. So what we are going to have is the root of our 2 minus 1 over, we have our root of 4 is 2, then minus 1 times the root of 3 plus 1 over root of 9 is 3 minus 1. So we are going to have something like the root of 2 minus 1 times the root of 3 plus 1 over, we have 2 minus 1 is 1. So we are multiplying times 3 minus 2 is 3 minus 1 is 2. Then we are going to finally have the root of 2 minus 1. Then we have the root of 3. Then we have plus our 1 like that. over we have a 2. So you can end here or you can continue to expand this. So otherwise we have rationalized the denominator for that one. So this is the meaning. On the denominator there should not be any radical or a root. Okay, so if your lecturer likes expanding, you can expand this or you can leave it like this. So let's move on to our next problem. So C says determine whether the function f of x is even, odd, or neither. So just by looking at a function you are able to determine. So our f of x should be equal to x to the power 4 plus our x to the power 2 plus 1. So this one, just by looking at it, you can tell that this is an even function. So an even function will have, the powers will be even, then we can even have a constant number like that. So this is even. So if the powers are even 4, 6, 8, 10, 12, then that means to say it is even, provided that we don't have any odd power on x. Then we could have a pure number like that. So we are going to go direct to test for even. If it is even, we are going to say, if it is even, we are going to say f of x should be equal to f of negative x, like that. So we know that f of x is equal to, we have x to the power 4 plus our x to the power 2 plus our 1. Then our f of negative x should be equal to, where there is x, put negative x, then we have power 4 plus, where there is x, put negative x to the power 2 plus our 1. So negative x to the power 4 is equal to positive x to the power 4. Then we have plus negative x to the power 2 is positive x to the power 2 plus 1. So if your f of x, you can say, since f of x is equal to f of negative x, you can say then it is even. Just this, it will guarantee you the 5 marks. Let's move on to our next. So looking at this other question, it says that a is equal to a member of real numbers such that our negative 4 is less than x, less than or equal to x, less than 2, like that. So this is our a. Then our b is equal to x is a member of real numbers such that our x should be greater than or equal to negative 1. So the easiest way to answer this is to draw the number line to show what these represent. So we are going to have something like this. Then for a, we have a negative 4 and the highest value is a 2. Then we are going to go at 4. Since 4 is included less than or equal to, it means to say we are going to shade this. Then at 2, it is saying less than, so we are going to have this. So we are going to have something like this. Then for our b, it's saying that you include your negative 1 like that. So we are going to go at negative 1. Then move. If x is greater than negative 1, it means to say it is going to be going this way. So yeah, so including this negative 1. So to answer the first part, it says a intersection of b. So a intersection of b, the things in common are, if we shade, it's this. So the answer for that one will be equal to, representing it, it will be a negative 1 less or equal to x less than 2. If we are to move from this interval until we meet where 2 is. But 2, according to this, it's not the intersection, because this is an open circle, meaning to say it might be common for this one, but it's not for this other one because it's an open circle. So in other words, this can be written as, we have negative 1 like that, and a 2 like that. So either this or this, unless they specify what they want. Then what we are going to have is, for our second one, A complement. A complement means exclude A. So if we have our A negative 4, 2 like that, then what we are going to have is our A complement will be, if this is our A, it will be including from here going forward like that. So this will be a closed circle, since for A it is open. Then we are going to also have something like from here going to there. Since this is an closed circle, it will be an open. So this is our A complement, this is our A complement. So we are going to say that our x is less than negative 4, or we can have our x should be greater than or equal to, we have a positive 2 like that. So this in interval notation means from negative infinity to negative 4. If you want more on intervals, just comment. Then all means union, we are going to have something like this. So this is the interval notation. So that is how we solve that one. Let's move on to our next question. So we have the next one is saying, what are the dimensions of the largest rectangular field which can be enclosed by 1,200 meters of fencing? So already it is a rectangular field, meaning to say it will look like something like this. So let's call one side x. So let's call this side x. This will be our y, this will be our x, this will be our y like that. So that is the meaning. So if we have 1,200, that's the perimeter. That means to say this the fencing has been made of 1,200 like that. So that's the perimeter. So perimeter is the sum of all the sides of a given shape. So we can be able to say, if I add my x plus my x plus my y plus my y should be equal to, we are going to have a total of 1,200 meters. So x plus x should be equal to, we have our 2x plus y is our 2y, should be equal to 1,200. So what we are going to do from there is, we are going to divide throughout, so that we remain with simple numbers such as x plus y should be equal to 1,200 divided by 2 is a 600. So this is the perimeter equation. So the perimeter equation is equal to this. So we are going now to say the area of a triangle is equal to, we have our product, which in this case the area should just be able to be, so the area should be equal to x times y. That's the area of a triangle, x times y of a rectangle. So what we are going to do is that we are going to make one of the letters the subject of the formula. Let's make our y the subject of our x the subject of the formula. If we take y there, it will be x is equal to 600, then minus our y like that. So where there is x, we are going to put this. So the area should be equal to, we are going to have, where there is x, we are going to put our 600 minus y times our y like that. So we are going to open y times 600, it will be 600y. Y times y, it will be y squared like that. So this is our area. So our area will be equal to, we are going to have, let's factorize the negative first. This is going to give us a negative 1, open brackets. We are going to have negative 600y. Then we have plus our y squared like that. Then what we are going to have is, we have a negative 1, open brackets, just rearranging them. So we have y squared minus our 600y. Then from there, what we are going to do is that let's use the completing of the square. If you haven't watched that, comment in the section. So we have -1, then we are going to have our y squared. Where there is 600, we are going to have minus 600y. We are going to maintain it. For the next part, we are going to add the square of this number, which is just the coefficient -600 over our 2. We divide by 2, then square it. Then whatever you do, you add, you are also going to subtract so that they cancel each other. So negative, open brackets, -600, then we divide over our 2 like that, squared. So we are going to have -1, then we have a y squared minus, let's ignore this, y squared plus our 600 divided by 2, it will be -300 squared minus, we are going to have 300 as well, then we have our squared like that. So what we are going to have is that the one that is adding, we are going to combine them. So we have -1, then we have y, whatever value is there, minus 300, then we have our squared like that. Then 300 squared, this will give us a -90,000 like that. So this is what we have. Then after we are done with that, we can multiply throughout. This will give us a -1, open brackets, y minus 300 squared. Negative times negative, it will be positive 90,000 like that. So this is what we have. So if you are asked to find the maximum area, so this is your maximum area. Then to find the dimensions, we are going to get our y minus 300 to be equal to 0. Whether you put squared, as long as you are equating to 0, it will cancel. So we are going to get this equated to 0. Take the 300 the other side, y should be equal to 300 like that. Then we know that x plus y, we found that it is equal to 600. So where there is y, we put 300. So we have x plus 300 should be equal to 600. So x is equal to 600 minus 300, which will give us x is equal to 300 like that. So the dimensions for maximum area should be equal to 300 meters by 300 meters like that. So that is how we obtain such values. Let's look at our last problem. For our final, we have sketched the graph of, we have our 2x plus 1 on the same diagram. Sketch this and hence find the values such that the square root of that and that gives you that. So we are going to begin with our f of x. Let's begin with our f of x is equal to, we have our 2x plus 1. So this one, the absolute value, we are going to begin. We know that our mother graph looks like something like this. So something like this. This is our mother graph, which is literally our y is equal to the absolute of x. So if we have this, we are just going to apply each and everything. So this helps us to know to say it will go up like that. So what we are going to have is that we are going to just get two very important points, which are where the graph passes the y-axis. So where the y-intercept x is equal to 0. So y-intercept x is equal to 0. So get 0, put it there. We are going to have y should be equal to, we have the absolute value of our 2, where there is x we put 0, then we have a plus 1 like that. So y should be equal to, we have 12 by 0 is 0, plus we have 1 like that. So y should be equal to 1 like that. So this graph passes at positive 1 like that. So we are also going to just see where the shift will be. So we just get this equated to 0. So we are going to have 2x plus 1 should be equal to 0. Take the one the other side, it will be 2x should be equal to negative 1. We divide by 2, we divide by 2. So this is where we have our x is equal to negative 1 over our 2. So the graph will start at, let's say if this is 1, negative 1 over 2 is here. So negative 1 over 2 like that. Then it will pass at 1 like that. So this is our graph. This is our first graph. Now what we have is that we have this second part, g of x. So our g of x is equal to, we have the square root of our 1 minus our 2x like that. So we are going to make sure that x is just without, it is equal to positive x and it is not having any coefficient. So our g of x should be equal to the square root of, we have factorizing, we are going to have a negative 2. We are going to remove negative 2 so that x remains alone. So we are going to have negative 2 divided by 1, it will be negative 1 over our 2. Then we are going to have negative divided by negative is positive. Then we have our x like that. In such a way, if I multiply negative by half, negative half, it will give me positive 1. Negative by x, it will give me negative 2x, meaning I can go back to my original equation. So my g of x should be equal to the square root of, we have a negative 2. Rearranging this, we are going to have our x minus 1 over our 2 like that. So this is the same as having the square root of negative 1 times 2 times the x minus 1 over our 2. So this is going to give us something like, just remove according to the properties of radicals. So let us even write like this. So we have a 2 and a negative 1, which is still the same. Then we are going to separate the square root of 2 from the square root of negative 1. Then we have our x minus 1 over our 2. Now remember, the mother graph of this other equation looks like something like this. So it goes this side as long as we have a negative inside here. So if we have a negative inside, it goes the other side like that. Then what we are going to do is that we are just going to know the new shift by getting x minus 1 over 2 equating it to 0. So x minus 1 over 2 should be equal to 0. So our x is equal to positive 1 over 2. So we are going to go at positive 1 over 2, which is here. Then we are going to find out where does the equation pass. So we are going to find out where the equation passes. So for g of x is equal to this, then all we have to do is that find the y-intercept when x is equal to 0. So g of 0 should be equal to the root of, we have 1 minus our 2, 0. So we are going to have the square root of 1 like that. So the square root of 1 is we are going to take positive 1. So it will pass at the same point like that. So it will be something like this. Let me try to use the other one. So they meet at that point. So this is our y. g of x should be equal to the square root of, we have our 1 minus 2x. For this other one, this is our modulus graph, which is this equation identified. Then last but not the least, we are told find the value of 1 minus 2x and the absolute of this. So we have been now told to find, so we are going to find where the radical equation is greater than the absolute value equation. So in terms of the y, so we are going to compare the two equations. So as you can see, at this point, the value of y is equal to 0, but the value of this one is greater. So at this point, the value is greater for this other equation. Even at all points this side, you will find that the only point where they are equal and where they are no longer satisfying, it is the point at which the two lines intersect. At this point they have the same value, but as we look at just this region in general, we are going to find that the y value is greater. So what we are going to do is that we are going to just get, now if the scale, if it was drawn to scale, we can just find it, we can just be able to identify it. But we have, number one, we have a 0, so we just want an interval from to here, so we need to just find this value. So what we are going to have is that we are going to say, so at the point where the two equations meet, they are equal. So we can say at the point of intersection, their x values are equal. Their x and y values are equal. So we can equate them. So we are just going to say the square root of 1 minus 2x should be equal to the 2x plus 1. So the relationship between absolute values and the absolute values and what else? Absolute values and the root is that they can both be removed by squaring both sides. So we are going to have 1 minus 2x. Then here we are going to multiply, should be equal to, we are going to have our 2x plus 1. Then we have 2x plus 1 again. So this will give us 2x multiplying everything. It will be 2x, open brackets, 2x plus 1. Then we have plus our 1. This one multiplies everything. We have our 2x plus our 1 like that. Then we have 1 minus our 2x. So we are going to have 1 minus 2x is equal to this times this. It will be a 4x by x. It will be 4x. This times this. We are going to have 2x times 1. It will be, so we have squared. Then we are going to have plus 2x. 1 times, we are going to have 2x plus our 1 like that. So what we are going to have is that, let's collect the like terms. So when we collect the like terms, we are going to get a, so we are going to have something like this. So we have 1 minus 2x should be equal to, let's take the 1 the other side and the x, so that here we are going to remain with 0, should be equal to 4x squared plus 2x is a 4x. Then we have plus 1, plus, if this comes there, it will be plus 2x plus 1. 1 when it goes there, it will be minus 1. So we are going to have 0 should be equal to 4x squared plus this will give us 6x. 1 minus 1 is 0. Then what we are going to do from here is factorize. So 2 is common, x is common, then we have our 2x plus our 3 like that. Then what we are going to do is that equate, so this means our 2x is equal to 0, or our 2x plus our 3 is equal to 0. So our x is equal to 3 over our 2x should be equal to, we take the 3 the other side, it will be -3. We divide 2, our x should be equal to -3 over 2. Here we divide 2, our x is equal to 0. So these are our values. So as you can see, that's the region there. So at this region, so we have a 0 here, we have another point there. So what we are going to do is that we are going to get a, so the interval is from 0 and a -3 over 2. So we are going to say -3 over our 2 should be less than x, while x should be less than 0. So at this interval, the equation, this radical equation, is greater, just as I have said. So this is the answer for that one. Thank you very much for watching. Hope you would like, subscribe, and share for more. Don't forget to like so that my video can reach a broader audience, and subscribe just for support. See you in the next tutorial.